Do you know the difference between frequency and frequency distribution? If not, then this video is for you. In today's video, we will be discussing what is frequency, why do we need frequency, difference between frequency and frequency distribution, types of frequency such as absolute frequency, relative frequency, cumulative frequency, relative cumulative frequency, and how is frequency represented. Hey champions, if you are interested in these topics, then keep on watching. You can subscribe to our channel for more such videos. Before we get into the nitty-gritty details, let's start with the basics. But before that, let's first understand what exactly frequency is. In statistics, frequency refers to the number of times a particular value occurs in a dataset. That is, it is a measure of how often a specific event or outcome occurs. This concept is fundamental for describing and analyzing data distributions, making it easier to identify patterns and trends, which facilitates data exploration, analysis, interpretation, and decision-making across various domains. Let's now try to understand why we need frequency. Frequency is essential in statistics for several reasons. Data summarization. Frequency helps in summarizing large datasets by providing a concise representation of the distribution of values. Pattern recognition. Frequencies help in identifying patterns and trends in the data. Data exploration. Frequency distributions allow us to explore the characteristics of the data using central tendency, dispersion, and shape of the distribution. Comparative analysis. Frequencies enable comparison between different datasets or subgroups within a dataset. Predictive modeling. Frequency distribution serves as the basis for building predictive models and making statistical inferences. Decision making. Frequency provide valuable information for decision-making processes in various fields. Hypothesis testing. In inferential statistics, frequency are crucial for hypothesis testing and making statistical inferences about the population. Now, before we move on to the types of frequency, let's see the difference between frequency and frequency distribution. In statistics, both are related concepts, but they have different meanings. While frequency refers to the count of occurrences of individual values in a dataset, frequency distribution, on the other hand, is a tabular or graphical representation of the frequencies of different values in a dataset. Frequency provides a raw count of how often each value appears without organizing or summarizing the data further. But frequency distribution involves organizing and summarizing the frequencies of different values in a dataset and providing a comprehensive overview of distribution pattern, shape, and characteristics of the dataset. For example, in a dataset of test score, the frequency of a score of 80 might be 3, indicating that the score 80 appears 3 times in a dataset, while the frequency distribution of the test score dataset might show the scores 70 to 79, 80 to 89, and 90 to 100 along with their respective frequencies. In summary, while frequency refers to the count of occurrences of individual value in a dataset, frequency distribution provides a structured summary of these frequencies, organizing them into categories or intervals, and presenting them in a tabular or graphical format for easier interpretation and analysis. Let's now see different types of frequency and understand each of them using examples. First type of frequency is absolute frequency. It is the actual count of occurrences of each unique value. First, the dataset's unique value are analyzed, followed by counting of occurrences of each unique value. We'll try to understand this type of frequency using an example. Consider a dataset representing the ages of individuals in a small community. To find the absolute frequency, we will first analyze the unique ages in our dataset, and then we will count the occurrences of each unique age to get the frequency. As you can see, 25 occurs 4 times in a dataset, 28 occurs 6 times, and so on. Next type of frequency is relative frequency. It is the proportion of the total number of occurrences that a specific value represents. It is calculated by dividing the absolute frequency of a value by the total number of observations in a dataset. For our example, step 1 is to calculate the absolute frequency of each age, and next step is to calculate the proportion of each age relative to the total number of observations by dividing the absolute frequency of each age by the total number of observations, which is 20 in this case. Relative frequency of age 25 is 4 divided by 20, which is 20%. Relative frequency of age 28 is 6 divided by 20, which is 30%, and so on. Next type is cumulative frequency, the running total of frequencies as values increases in a dataset. To calculate the absolute cumulative frequency, you start with the frequency of the smallest value and add the frequency of each subsequent value to the running total. The last cumulative frequency will be equal to the total number of observations in the dataset. In our example, first we will calculate the absolute frequency, and then to calculate the cumulative frequency, we will start with the frequency of the smallest value and add the frequency of each subsequent value to the running total. That is, we will add the frequency of age 25 to that of age 28 and then add that sum to the frequency of the next stage. We will continue this process until we reach the last stage. Last type of frequency is relative cumulative frequency. Relative cumulative frequency is the running total of the relative frequencies of values in a dataset. To calculate the relative cumulative frequency, you start with the relative frequency of the smallest value and add the relative frequency of each subsequent value to the running total. The last cumulative relative frequency will be equal to 1 or 100% if expressed as percentage. In our example, first we will calculate the relative frequency, and then to calculate the relative cumulative frequency, start with the relative frequency of the smallest value and add the relative frequency of each subsequent value to the running total. That is, we will add the relative frequency of 25 to that of 28. The sum is then added to the relative frequency of the next stage. We will continue this process until we reach the last stage. Let's now look at how frequency is represented. Frequency can be represented in various ways, depending on the context and the type of data being analyzed. Here are some common ways frequency is represented. Frequency tables organize data into tabular form with counts for each value or range. Bar charts visually compare frequencies using bar of varying height. Histogram graphically display numerical data distribution with bars. Frequency polygon line graph connecting midpoints of histogram bar show frequency distribution. Cumulative frequency graph plot cumulative frequencies against interval for analyzing cumulative distributions. Choice of representation depends on the nature of the data and the specific goal of analysis. We will cover each of these topics in detail in an upcoming video. That's it for today's video. You can share your thoughts or questions in the comment box. Subscribe for more such videos. Bye and meet you in the next one.